Okay, so I know you're super disappointed that we didn't get to do any notes in class, so I figured I would take a moment to review the concept of intercepts. I am sure if you were inclined to do so, you could read a little bit in your textbook, or you probably remember a lot of stuff anyways. So of course, this is the point or points where the graph crosses the x or y axes. If you cross the x-axis, I hope you remember that's when your y value happens to be 0. Where you cross the y-axis happens to be when your x value happens to be 0. The fun gets to come into when you have different types of equations. So for example, let's say we had the function y equals x squared plus x minus 2. I hope you all recognize that's going to be a parabola because it has a degree of 2. So we know that we could have two x-intercepts, one x-intercept, no x-intercepts, and definitely one y-intercept. So finding the y-intercepts is pretty darn easy itself. All you have to do is substitute a 0 in, obviously. And voila, we have our y-intercept at 2. Now in calculus, there is not going to be much differentiation between you writing y equals 2 as your coordinate or your actual point value of 0, negative 2. Both should be acceptable. One of the things we're going to make sure we talk about in class is how much work do we have to show and how much do we have to explain. So I will do my best to make sure that I point out all of these things to you as we work through the course. So where it gets fun though is your x-intercepts. Those are always a little bit trickier. And here's in calculus where things get interesting. Calculus itself is not hard. It's the algebra that always gets everybody. So we're going to replace the y value with 0. And I hope you recognize quadratics and remember your friend, my friend, and everybody's friend. Factoring is going to play a role. Yes, you could use quadratic formula, but I always check to see if anything factors. Are there factors of negative 2 that add up to give you a positive 1? If there are, why would you go through the hassle of the quadratic formula? And in this case, there happens to be two values. Positive 2 and negative 1 satisfy those conditions. The zero product property that tells us that each one of these two values has to be set equal to 0 in order for this to be a true statement. And therefore our two x-intercepts are x equals negative 2 and x equals 1. Now, weirder expressions, not really the good mathematical term for these, but nevertheless fun. Definitely not going to be a polynomial. You've got a radical in there, you've got something in the denominator, and I hope we remember as soon as we see this denominator, you've got to think restrictions. Remember, 0 can never, ever, ever be in the denominator, so without actually doing any work, right away you should be able to surmise that x can never equal 0 because you've got yourself a vertical asymptote at that particular point. Which means if x can never equal 0, you have no y-intercept. Now this is an interesting point with the AP exam. If there was a fact that you had to write down that there was no y-intercept, and you were asked to justify your answer, you would have to tell me why. So justifying tells me why is it true? And there is no y-intercept because there is a vertical asymptote at x equals 0. Short, sweet, clear and concise, and to the point. Okay, but then we get to go back and we get to find those fabulous x-intercept or intercepts. So again, we're going to replace y with 0. And as soon as I see a fraction on one side of my equation, I'm going to create a fraction on the other side. So we can create anything turn anything to a fraction by putting it over 1. Because now what I can do is I can cross multiply because I have myself a proportion. And that greatly simplifies the process. Goal is to get x by itself, so I'm going to subtract 2 from both sides. I've got that negative in front there, so we've got ourselves 2 is equal to the square root of x. And the opposite of a square root is to square it. So we've got 1 x-intercept at x equals 4.